Chapter 7 Prerequisite Review. I'm going to look at numbers 24 through 32. Number 24. The directions for all of these are to simplify, and if the final expression involves a fraction or fractions, make sure to rewrite it over a common denominator so that it's a single fraction. Fully factored, we'll talk about that. So for number 24, x over x squared, I'll just remind you that really this is 1 times x over 1 times x. So the pair of x's here will cancel those common factors, and the final answer is 1 over x. In number 25, to multiply these, I'll put that y over 1, and I have xy over 1y, or over y, and my y's that are common factors in both the numerator and denominator will cancel out. So the answer is x over 1, which is, of course, just x. For 26, multiply across the top and across the bottom. And you can see that the common factor of x that's in the numerator and denominator will cancel, and we're left with 1 over y. So these three, very basic. Okay, number 27. Let me look back here. Simplify. If the final expression involves fractions, we're going to rewrite this over a common denominator. So I can't simplify this. Now I'm just going to write it with a single denominator. The common denominator for these two, if we look at them as fractions, is x squared. So if I multiply by x squared over x squared, this is what I get. And I can add these two fractions. The numerators combine, or can be written as a single numerator over x squared. Okay, remember that if you're tempted to do this and say those x squareds cancel, you need to catch yourself and remember that that is not mathematically sound reasoning there, because in the numerator, that x squared is a term, not a factor. It's being added to y squared, so you can't cancel it. It's not a common factor in the numerator and denominator. For 28, the product of the numerators is xy squared. The product of the denominators is y. And so the factor of y in the denominator cancels with one of the factors of y in the numerator, leaving xy for the answer. Number 29 needs to be simplified. What I'm going to recommend doing first is get the denominator written as a single fraction, so then you can multiply by its reciprocal. So I'm going to multiply y by x over x, so that my two fractions in the denominator are 1 over x minus xy over x, which can be written as 1 minus xy over x. And so now we know that to divide by a fraction, we can instead multiply by its reciprocal. So I'll take x times the reciprocal of that fraction. So it'll be x over 1 minus xy. And if I multiply these two fractions, x times x gives me x squared in the numerator over 1 minus xy in the denominator. Number 30 is the same process, kind of reversed. So again, this time my common denominator is going to be y, multiply by y over y, and I get x divided by xy minus 1 over y. And so remember that to divide by that fraction, I can instead multiply by its reciprocal. So x times y over xy minus 1 gives me xy over xy minus 1. For number 31, I'm going to simplify the numerator a little bit first and write that as x over xy divided by 1 over y. And then remember there's a 1 here and those x's will cancel in that fraction that's in the numerator, so I have 1 over y divided by 1 over y. Well, immediately anything divided by itself is 1, but if you don't recognize that, you might rewrite this as 1 over y times y over 1, which is y over y, which is 1. Any way you go about it. Number 32, these two fractions have a common denominator already, so I can write them as a single fraction, 1 minus y squared over x squared. And I think when we get to our trigonometry unit, that's where you'll pretty much stop and then you'll do something else. At this point, I'm still wanting you to be recognizing when you can factor, and 1 minus y squared is a difference of 2 squares. So technically, maybe to follow the instructions, you could factor the numerator. Generally speaking though, there's not a whole lot of point to taking this final step of factoring if nothing's going to cancel when it's factored. And so there's still no common factors that are going to cancel. That fraction doesn't reduce at all. So the first answer is probably just fine.